Hello my friends, here we're going to be doing this solution for the problem, and this is a fluid mechanics. So the question is on fluid properties under viscosity. So a plate 0.025 millimeters distant from a fixed plate moves at 60 centimeters per second and requires a force of 2 newtons per unit area. So this is 2 Newton per square meter. To maintain this speed, determine the fluid viscosity between the plates. So let's first draw the fixed plate, and we are told that there is a plate that is moving past this other plate. So this is the one that is moving at a distance, at a speed 60 centimeter per second, and there is a fluid in between the two plates. So this is a fixed plate. This is a moving plate. So what is this? This is 60 out of 100 meters per second, 0.6 meters per second. That will be the speed. So you will find that since it is moving from this one speed is 0 and this is u, so we'll find that the change in speed will be du, which will be u minus 0. This becomes 0.6 minus 0, and du becomes 0.6 meters per second. Now the force per unit area is tau. Tau is measured in Newton per square meter. So we are given that it is Newton per square meters. So determine the fluid viscosity. So the separation in between is what we are calling dy. So what is dy? Again, we are seeing that dy is 0.025 millimeters, which is the same as 0.025 times 10 power negative 3 meters. So tau will equal to nu times du dy. That is Newton's law of viscosity. So what does that mean? Here we are going to just substitute in and make new the subject. So this is 2 divided by du. Du is 0.6 divided by 0.025 times 10 power negative 3. And this obviously is going to give us, from my calculator, nu is 8.33 times 10 power negative 5, and this is in Newton second per square meter. So in Poise, this is nu will be 8.33 times 10 power negative 5 times 10. So this becomes 8.33 times 10 power negative 4 Poise. So that's how we can calculate that. So the next problem says that a plate 0.05 millimeter distant from a fixed plate moves at 1.2 meters per second and requires a force of 2.2 newtons per square meter to maintain this speed. Find the viscosity of the fluid between the plates. Again, we have our fixed plate and a moving plate, and in between them we have a fluid. This is moving at 1.2 meters per second. The distance in between them is 0.05 millimeters. So this is dy is equal to 0.05 millimeters, and this is 0.05 times 10 power negative 3 meters. What about du? The change in speed or change in velocity is this is at u is equal to 0, this is at u is equal to that. So that will be 1.2 minus 0. This gives us 1.2 meters per second. Then if they tell you that it requires a force of 2.2 newtons per square meter, if it has a square meter, then it means this becomes tau, which is shear stress. If it is only a force, it would be 2.2 newtons. So that means that tau is also given as 2.2 newtons per square meter. So therefore, nu will be tau out of du dy. And that becomes 2.2 divided by what? Du dy. Okay, this becomes 1.2 divided by 0.05 times 10 power negative 3. So nu becomes 9.16 times 10 power negative 5 Newton second per square meter. And in Poise, this becomes 9.16 times 10 power negative 5 times 10 Poise. And obviously, this becomes nu. Our viscosity becomes 9.16 times 10 power negative 4 Poise. The next problem here says a plate having an area of 0.6 meters squared is sliding down an inclined plane at an angle to the horizontal with a velocity of 0.36 meters per second. There is a cushion of fluid 1.8 millimeter thick between the plane and the plate. Find the viscosity of the fluid if the weight of the plate is 280 newtons. So first of all, the plate has an area 0.6 meters squared. Velocity u is 0.36 meters per second. Dy, which is the thickness of the fluid, is 1.8 millimeters, which is 1.8 meters times 10 power negative 3. Now the force, if the weight of the plate weight is 280 newtons. So let's draw that. So this is the weight of the plate. This is weight W, and obviously this is what we call W cos theta, and this is W sin theta. So according to the mechanics that we know, mechanics of an object on an inclined plane, if it is static, these forces always appear there. Okay, so we have now the velocity. U is in that direction also, 0.36 meters per second. So the angle here is supposed to be at an angle of 30 degrees to the horizontal. So this is supposed to be 30 degrees. So that makes the whole thing simple now. So to get the force, the shear force would be W sin theta, which becomes 280 sin 30. And that brings the whole thing to 140 newtons. Because sin 30 is 0.5 times 280 that becomes 140. So what else? Shear force is that. Now we need area. Area is given as 0.6. So we know that shear stress tau is equal to the shear force out of the area that is under shear. So tau becomes shear force. It's 140 divided by 0.06. 0.6. So this becomes 233.33 Newton per square meter. So what else? We need to know du by dy. Du by dy, du first of all is known. Yeah, this is 0.36. That is du, 0.36 divided by dy. dy is known as 1.8 times 10 to the power negative 3 meters. So divide by 1.8 times 10 to the power negative 3 meters. So that means nu will be tau divided by du dy. And this obviously becomes 233.33 divided by this value, 3.6 times what? Okay, it's nothing. Divided by 1.8 times 10 power negative 3. So nu becomes 1.166 Newton second per square meter, and in Poise we multiply by 10. So 1.166 times 10 becomes 11.66 Poise. So that gives us the viscosity of the fluid that is in between the inclined plane and the plane. Thank you. Remember to subscribe, share, and comment.